Yes, like today we're supposed to explain the bipolar AMI technique and pseudo ternary. Okay, the bipolar AMI technique, it is a alternative mark inversion method and pseudo ternary method. Okay, the alternative mark inversion technique, it contains the two levels of or two set of voltage, that is zeros and ones. Okay, if zeros means it should be negative voltage, and if it is one means it should be a positive voltage. Like that, based on that voltage we have to draw the timing diagram. See, you look at this is the time slot. Okay, this is the x-axis and this is the amplitude is y-axis, and x-axis will be time. Okay, within that time and amplitude we supposed to draw the means timing signals. Okay, that is the digital signal. See, if it is 0, it should be a lower voltage. Okay, if it is 1, yes, it should be a high voltage. See, like that, if it is 0 low, if it is 0 low, and if it is 1, yes, it should be a high voltage. Okay, like that. Okay, we supposed to draw the AMI technique. Okay, then, what is the pseudo ternary? The pseudo ternary, okay, it is the inverse of our AMI technique. Okay, why? Because I told, right, see, like if it is alternative ones, okay, in that time the signal, it may be a got change. See, but like before, like first, okay, initially we got first like 1, the value of 1, okay, it should be a higher to means it should be a high voltage value. Okay, the next time the value of 1 we got, during that time we supposed to change the signal, means we supposed to use the alternative signal. Okay, previously I have used the positive signal. Okay, the next time again we got first means of the value bit will be 1. So during that time I am going to change the alternative value, that should be the negative value. See, this will be negative value. See, this is the technique of our AMI method, bipolar method. But what is the pseudo ternary method? It is the totally opposite. Okay, this is the totally opposite or totally inverse of our AMI technique. Okay, wherever we got 0, okay, during that time it is going to alternate the voltage. Okay, wherever we got 1, it should be a positive value. See, if it is 0, okay, I am going to taking as a positive, because it totally inverse of our AMI technique. Okay, if it is 0 in pseudo ternary, okay, the signal will be positive, but AMI, the 0 will be negative voltage. See the difference. Okay, see, AMI, if it is 0, but pseudo ternary, the signal value will be 1. Okay, means positive. Okay, if it is like the value of 1 is here in pseudo ternary, it should be a negative value. Again, if it is 0, yes, it is going to negative, because alternatingly I am going to changing here. See, I am going to change. Okay, the pseudo ternary, always the 0th value it is going to get going, alternatively going to change the digital signals. Yes, if it is 0, yes, it should be a positive, because previously should be negative. Again, now it is going to change. Again, if it is 1, yes, it should be a negative voltage. Again, if it is 0, yes, it should be a negative voltage. Like that, it is going to keep on changing. The next one is, what is the analog to digital conversion? The analog to digital conversion, okay, here, yeah, here, we supposed to discuss about the analog signal, such as such as our analog signal will be sine wave. Okay, that is one of the best example of our analog signal. Okay, then why we supposed to use the analog signal to digital data in this technique? Make whatever like we are giving, or whatever we have given the analog signal, that it is going to convert it as a digital signal. Suppose, okay, I am passing the analog signal. Okay, it may be a sine wave. Okay, that sine wave, it is going to convert it as the digital signal. Okay, so this is the method we call it as analog to digital conversion. The analog to digital conversion, here we supposed to use different types of techniques. that is pulse code modulation and delta modulation. Okay, the pulse code modulation, why we supposed to use here pulse code modulation? The most common technique, see, the most common technique of our pulse code modulation is, and it is going to changing the analog signal to digital signal or digital data. Okay, this method we call it as a pulse code modulation. Okay, see, the pulse code modulation, it contains the encoder, or it is going to encoder, it is going to encode the three type, okay, three process, okay, three process, that is sampling, quantizing and encoding. Okay, we cannot change the analog signal into digital signal. Okay, before that we need three types of process, or three types of steps. Okay, the step by step we have to convert the analog signal into digital data or a digital signal. See, this is the analog signal. You look at the signal. So this is the one of the pulse code modulation components, okay, which we have using here. That is PCM, encoder, quantization, quantized signal. Okay, PAM, that is pulse, pulse code amplification module. Okay, modulation, pulse code amplifier modulation, that we call it as a PAM signal. To overcome this PAM signal, we use the pulse code modulation. Okay, so this is the analog signal. Okay, this analog signal, it is going to, yeah, it is going to reach the sampling and quantizing and encoding. Okay, what is the sampling, quantizing and encoding? Okay, we will discuss one by one now. See, before that, our pulse code modulation, it is going to take care the three tips. That is the initially our analog signal, it is going to convert as this samples. Okay, that sample signal, it is going to convert as, or it is going to transfer the quantized, that whatever the quantized value, that are going to encode it in the form of sequence numbers. Okay, or it is a group of bits. Okay, that bit we call it as a digital data. Then what is sampling here? The sampling in PCM, that pulse code modulation, the analog signal, it is going to sampled like every time per second, or every time per like each and every sample time. Okay, where TS is the sample interval or period. Okay, the TS is the sample interval time, or it is the interval period. Okay, that inverse of the sample intervals, we call it as a sampling rate. Okay, or sampling frequency, that we denoted as the like double, this one is like two times of sampling time. Okay, there are three sampling method, that is ideal, natural and flat top. See, this is what the sampling here. See, the sampling is nothing but it is going to divide, or it is going to segregate it. It is going to segregate it the it is going to divide the analog signal. See, based on the amplitude. See, it is going to divide the signal based on the amplitude. See, your amplitude will be, you look at this, how it is the analog signal will be happen. See, initially it should be very low, then little bit high, and little bit, then the peak will be high, again it should be low. See, based on this analog signal, it is going to divide the that particular signal into in the form of samples. So okay, the dividing part, we call it as a sampling with the help of amplifier. Okay, see, this is method we call it as a sampling. Then what is the quantization or quantized signal? Before that, these all are the different methods of our sampling here. I mean, different methods of our sampling uh, method. That is one of the, that is the ideal sampling, as well as neutral sampling and flat top sampling. Okay, The common sampling method, we call it as a sample and hold, or it is going to create the flat tap samples by using